to the naked eye. They're known as phytoplankton. Although phytoplankton are no bigger than a pinhead, they're one of the most important forms of life on Earth. To understand just how important they are, take a look at them from space. Just off the British Isles, large patches of the sea are stained light green by millions upon millions of individual phytoplankton, known as blooms. These blooms appear around the world's oceans. And it's because phytoplankton are so abundant that they can affect the whole planet. For a start, they're a vital source of food. Without phytoplankton in the oceans, there wouldn't be any fish or turtles swimming around. Phytoplankton is the first meal in the ocean food chain. But surprisingly, as well as being a primary source of nourishment for creatures in the sea, these tiny organisms help all animals on Earth to breathe. Phytoplankton can do this because they photosynthesize. They turn carbon dioxide and sunlight into energy in order to live. And this releases a very important byproduct: oxygen. This process takes place on a global scale. All these green patches show areas of phytoplankton, and they're all producing oxygen, which fills the seas and the atmosphere. Oxygen is vital to all animals, in the sea, on land, and in the air. If it wasn't for humble phytoplankton, there wouldn't be enough oxygen to breathe. Phytoplankton produce something like 50% of all the oxygen on Earth, about as much as the world's forests and jungles combined. The ocean is the one place where we can't breathe unaided, and yet ironically, this is the very place that provides us with half our air supply. But producing oxygen is just the start of it. The secret to the sea's power over all life on Earth, its greatest power, is a vast network of currents that connect all the oceans on the planet. The complexity of this network was graphically illustrated by a curious accident. On the 10th of January 1992, an ocean freighter was caught in a big storm out in the middle of the Pacific Ocean. As winds and waves lashed the ship, two of its giant containers crashed overboard and their contents spilled out into the sea. What burst out of those containers was, bizarrely, a shipment of these plastic bath toys. More than 29,000 ducks were now adrift in the middle of the Pacific Ocean. No one realized it at the time, but this accident would eventually turn out to be one of the biggest experiments in the history of oceanography. These ducks were about to embark on an epic voyage of scientific discovery. The moment they hit the water, the plastic ducks joined a series of powerful ocean currents which scattered them in different directions. In just 7 months, some were carried over 3,500 kilometers, washing ashore in places as far afield as Hawaii and Alaska. But for other ducks, the voyage had only just begun. They had embarked on a treacherous journey north, up through the Bering Straits and into the Arctic Sea. For the next few years, the ducks were carried east in ice floes across the Arctic and out into the North Atlantic, finally coming ashore on the coasts of eastern Canada and northern Scotland. You know, these tough little plastic toys had been carried for thousands of kilometres across 3 different oceans simply by the power of those surface currents. And they're still turning up today. The ducks' epic journeys vividly reveal the complex system of currents that connect all the oceans together. Currents that are vital to life on the planet. They carry nutrients and oxygen that nourishes life, and heat that drives the climate. In fact, the oceans are giant reservoirs of heat that's been captured from the sun. When heat-sensitive cameras are used to reveal the temperature of the ocean, you can see how the heat is distributed. The warmest areas are, as you'd expect, near the equator, where the sun's rays are at their strongest. But the ocean's heat doesn't all stay at the equator. The network of ocean currents distributes it around the planet. It's like a massive central heating system. And one of those currents is pretty important to us here in Britain. It's perhaps the most famous of all the currents. It brings warm tropical water from the Caribbean and delivers it right here to the British Isles. It's known as the Gulf Stream, and this is one of the first places in Europe that it flows past. These are the Isles of Scilly, just off the coast of Cornwall. And since it's such a beautiful spring day, I thought I'd enjoy the warm, balmy Gulf Stream waters for myself. Well, if this shows you one thing, it shows you that all things are relative. I might not be able to feel the warmth of the Gulf Stream just by jumping straight in, but you can see the effects of it all over the place. Just not here. Winter temperatures in the Scilly Isles rarely fall below freezing, creating a near Mediterranean climate, allowing tropical plants and exotic animals to survive. That's because air travelling over the Gulf Stream picks up heat and moisture from the sea, and the Scillies are the first landfall for that warm, wet air. You get some idea of how powerful the Gulf Stream is by travelling around the world on the same latitude as the Scillies. Heat-sensitive cameras show the waters off southern Britain glowing a warm orange. But on the other side of the Atlantic, at the same latitude, greens and blues reveal the icy waters off Canada. The Gulf Stream is just one fascinating example of how the atmosphere and the ocean interact to drive the climate. It's easy to assume it's the atmosphere that drives our weather patterns. And of course, in part, that's true. But in terms of moving heat around a planet, it's ocean currents that are the driving force. There's actually far more heat stored in the ocean than is held in the atmosphere. And this means that changes in the ocean currents can have big effects on the weather around the world. In the Pacific, every few years, a warm current moves from west to east. It's seen here as an area of red and white. No one's quite sure why it happens, but we know it as the infamous El Niño, and it's responsible for transforming the weather across much of the globe. It brings torrential rain to South America, flooding the normally dry deserts.